We're going to do 8.5, day 2. Complex fractions. There are two different ways, really, of doing complex fractions, at least two common ways. I'm going to show you just one of them. There is another one, but I find that in math analysis, the other one tends to get people into trouble, whereas this one always works. So that's why this is the one I'm going to show you. It's not the only way to do these, but in my opinion, it's by far the best way. Okay? And again, my goal, guys, is to get you ready with the skills that will help you succeed next year in math analysis. That's my goal. So that's why I'm going to show you the method that's going to be the most useful one in math analysis. So we're going to talk about complex fractions. And what complex fractions are fractions inside of fractions. And so what we will typically have is we will have something that, for example, might look like this. So notice we have fractions inside of fractions. When you are working with complex fractions, this is the way that I would like to see you work with them. What you're going to do is you're first going to take just the numerator. And you're going to change it so that it's all one fraction. So what do I have to do to make this into one fraction? It is one fraction. So this one is going to stay the way it is. Now, is that always going to be the case? No. They start you off with a pretty easy one where the numerator is already one fraction. Now what we're going to do is we're going to get the denominator. And we're going to simplify it into one fraction. So what we're going to do is we're going to treat this as if it was one of the problems from yesterday's assignment. What do I have to get in order to add those together? Common denominator. What's my common denominator going to be? Yeah, we have an x plus 4 that doesn't factor. We have an x, so we need both of those inside of our bag. So we have an x and an x plus 4. So this is going to be something plus something over x, x plus 4. Just like last night. What's new on the bottom of the first one? X. We already had a 1 on the top, so we get 1x. What's new on the bottom of the second one? So we already had a 2, and now we glued an x plus 4 onto the bottom, so we need to glue it onto the top. Now we're going to put those together before we distribute. Which now this becomes 2x plus 8. So altogether we get 3x plus 8 over x times x plus 4. Is everybody with me on that? This then goes here. So now I made the numerator into one fraction, which on this particular one it already was, so we didn't have to do any work on that. We took the denominator off to the side and we made it into one fraction. So do you see that technically, guys, that could, worst case scenario, be like two problems rolled into one from last night? You might have to do one on the top and one on the bottom. In this case, we only had to do one on the bottom. Now look at what we have. We have a fraction. What does the fraction bar mean? So we have a fraction divided by a fraction. Another way of writing that is this. Doesn't that look familiar? This is what we did 2 days ago and the day before that. We don't divide by fractions. What do? Multiply by the reciprocal of the denominator. So this becomes times x plus 4 over 3x plus 8. Does anything factor on the top over here? Does anything factor on the bottom over here? Does anything factor more on the top here? Does anything factor on the bottom? So I made it into multiplication by the reciprocal. We made sure everything was factored. What can we do to simplify now? Cross cancel the x plus 4s, and we're left with 5x on the top and 3x plus 8 on the bottom. That's it. That's our final answer. Do you see how that works? Do you see that it's really just 3 problems that we already know how to do? Right? We know how to take the numerator and add fractions together with a common denominator. That's what we did last night. We know how to take the denominator and add fractions together with a common denominator. That's what we did last night. We know that instead of dividing by fractions, we multiply by the reciprocal and factor and cancel. That's what we did 2 and 3 nights ago. So it's really just 3 problems rolled into one. 2 of them from last night, 1 of them from the previous section. That's how you deal with complex fractions. Any questions about that? Okay, so that's all there is to it. So tonight what you're going to have is some more stuff from like what we did last night, and then you're going to have some complex fraction stuff. Let's look at another one. Let's look at this one where we have to do a little extra work. X over, let's do 2 over x minus 4 divided by 2 over x plus 3. Can we cancel the 2 over x's? No, because they're not factors. They're part of addition and subtraction problems. So what we have to do, guys, is we have to start by grabbing the numerator. 2 over x minus 4. And we need to make that into one fraction. What do I do first to make it into one fraction? Put the 4 over 1 and what? GCF, well, not GCF, but LCD, right? What's the lowest common denominator? Yeah, we need a 1 and an x, which is just x. So this is going to be something over x minus something over x. This was already over x, so that didn't change. What does this guy become? 4x over x, right? We multiply the bottom by x, we have to multiply the top by x. So this is now, when I put these together, 2 minus 4x over x. Is everyone okay with that? Now, can we do more with that? Yeah, actually we can. What can we do to the top? We can take out a GCF at 2. We're going to do that later, but right now we're going to leave it the way it is. Is everybody with me so far? Okay, the bottom. I'm going to grab the bottom. I'll do that down here. 2 over x plus 3. Again, we're going to make the 3 into 3 over 1. What's my common denominator going to be again? I'm sorry. Yeah, my LCD. 1 times x, which is just x. So this becomes 3x over x. So the whole thing is 2 plus 3x over x. That goes here. Is everyone with me? So I made the top into one fraction by itself. I made the bottom into one fraction by itself. Did I work with both of those at the same time? No, one at a time. Don't try and do too much at once. You'll get yourself lost. Now what do I do instead of dividing by fractions? Reciprocal of which one? The bottom one. Good. So 2 minus 4x over x times x over 2 plus 3x. Does anything factor in here? Yeah, we can take a 2 out of the top, right? Now, can we cancel anything? What can we cancel? Just the 2 x's, right? This x cancels this x. Does anything else cancel? No, because this is all one piece. You can't cancel a part of it. It's the whole thing or nothing. So in the end, we end up with a 2 and a 1 minus 2x on the top and a 2 plus 3x on the bottom. There's our final answer. That's complex fractions. Now, this is extremely important, guys, because when you get to things like trig proofs in math analysis, pretty much every single problem, 90+% of the problems become complex fractions. where you end up with things, you don't have to write this down, but you end up with things like 1 over cosine of x plus sine squared x over actually, I should have made it like this. Let's do it. No, it's okay. Cosine x, cosine squared x, cubed x, over 1 over sine x plus cosine of x over sine x. So what do? You take the top and you make it into one fraction by getting a common denominator and put it together. You take the bottom and you make it into one fraction by getting a common denominator, which this one already has, and putting it together. And then you take the top times the reciprocal of the bottom, and things start canceling and simplifying. Okay? It's trigonometry, but it's exactly the same process that we just got through going, or just got finished going through. Does that make sense to everyone? I don't mean does that problem make sense, but you understand that we're going to be doing the same kinds of things just with trigonometry when we get to math analysis next year. All right. So that's it. Any questions about complex fractions? Okay, the homework assignment then is the following.